Hello, welcome back. This is 6-2. We're talking Riemann sums. The past examples talked about calculating the Riemann sums graphically. In this example, what we're going to do is we're going to use a function to get output values to calculate a Riemann sum. Okay, so without further ado, we'll go ahead and look at example 5. And here they want us to approximate the integral using a midpoint Riemann sum. So remember, midpoint Riemann sum, we're going to take the midpoint of the interval. Well, they want 3 equal subdivisions. So since my integral runs from 0 to 6, so 6 minus 0, and I want 3 equal ones, that's 6 over 3, which means every 2 units I will have an interval. So I want the midpoint. So here's my midpoint, okay, at 1, and the output value is right there, so I'll make a height of a rectangle there. And the midpoint is, for this interval, is 3, so here's my midpoint. So I'll make the height of a rectangle here. And the midpoint for this interval is 5, so I'll make the height there at 5. And here is my Riemann sum. Now, the issue with this is, notice that I don't have nice, easy numbers to calculate. Some of these are approximated, but I do have a function. So if I want to calculate the integral from 0 to 6 of this function, x squared plus 10 to the power of 1/2 dx, okay, it's going to be approximately, again, okay, equal width, so 2 times the height of these functions. Well, what's the height of these functions? Well, again, your midpoint's here at 1, so that is f of 1. Okay, or sorry, your function evaluated at 1. So, well, I'll just use f of 1, even though that's kind of not accurate. Plus f of 3, that's the height, plus f of 5. I guess if our function was called f of x, then that makes sense. Okay, so all we're going to do is we're going to evaluate there. And this would be equal to, so if I plug in 1 here, 1 squared would be 1, so that gives you root 11. Now I'm going to plug in 3. This would give you the square root of 19 plus f of 5, and that gives you square root of 35. So here's a numerical answer. That is the area underneath the curve using the midpoint Riemann sum. Fair enough, right? Okay. Note that it is possible that f of x is not always greater than or equal to 0, and or that your subdivisions do not produce intervals of equal width. Okay, what this is saying is that our area could sometimes be negative, and that we could have different sized rectangles. But we can still approximate the values of a definite integral using a Riemann sum. So here's an example, and they want us to approximate the integral from -10 to 5 of 2 to the power of x minus 8 dx by using 5 right-handed rectangles. So that's important. We're using the right-hand method, whose widths are determined at the intervals separating the following x values. Okay, and I'm just going to mark these. So -10, here's the start of one interval, and -4. 0, 2, 3, and 5. Okay, so note if I want these intervals, and it's a right-hand Riemann sum, I'm going to go to the right value, and I'm going to go all the way up. So this interval is going to go all the way up here, okay, and I want this area. Okay, then for here, for 3, I'm going to go to the right-hand value. Well, notice it's 0, so that rectangle is 0. Then I'll go to the right-hand value for 2, okay, that's here. Okay, and then the right-hand value at 0, which is here. Okay, and then the right-hand value at -4, all the way to here. So here is the visual of the Riemann sums, and these are right-handed Riemann sums. And now I want to go ahead and calculate this. So from -10 to 5 of 2 to the power of x minus 8 dx, and this is going to be approximately, okay, it's going to be approximately equal to the width times the height. Okay, so we'll evaluate the width. So notice from this point, from -10 to -4, that width is 6. From -4 to 0, that width would be 4. From 0 to 2, that width would be 2. The interval here, this width is 1, but again, that total area is 0, so we're not going to calculate that. And then from 3 to 5, that width would be 2. Okay, so I have 6 times, now I need the height. Well, the height is determined by my right-hand value, the function value, so that's at -4. So I'm going to plug in 2 to the power of -4 minus 8, okay, plus now my height, my width, which is 4, times the height. Again, how do I get the height of this rectangle? Well, it's determined by my right-hand value, which is now at 0, so 2 to the power of 0 minus 8, plus, again, the width, which is 2, and I'll multiply times the height. The height of this rectangle is determined at 2, so 2 squared minus 8. I'm going to go ahead, well, I won't skip it. I'll just add it in. So, again, 1 times the height of this value at 3, so that's 2 to the power of 3 minus 8, plus my last rectangle, again my width is 2, and I'm multiplying times the height of the rectangle, which is determined by my x value of 5. So 2 to the 5th minus 8. Okay, whew, that looks pretty gnarly to simplify. Good thing on the AP Calculus test, right? You don't have to simplify. This is a numerical answer. You can box it. If you attempt to simplify and you make an error, you could lose the point. Okay, so better be safe than sorry. That's what Mama said. Okay, so that's Riemann sums. Catch you next time. Peace.